This is How Does a Tesla Car Battery Work? By Jack Vassau. Tesla's cars are thought of as the cars of the future. Elon Musk, the owner of Tesla, has been able to revolutionize the industry of electric cars and batteries. Although the Tesla Model S and other Tesla modeled cars are not the first electrical cars on the market, they have been able to innovate and improve on previous designs to make something that is not only workable, but is also surpassing many conventional motors. The Tesla Model S doesn't only have great motor efficiency and cause no pollution on the consumer level, because obviously there is pollution caused in the manufacturing, but also the Model S is the fastest accelerating car in the world. But what makes the Tesla Model S and the Tesla cars so revolutionary? And what makes it different from other electrical cars? The key is in the battery. A battery is anything that converts stored chemical energy into electrical energy. Here, we see an example of disposable Duracell batteries that you can buy at any convenience store. Batteries range from these, the small and simple, that can power anything up to a flashlight, to the more complex, things that can power a car or even your own home. A battery is made up of three basic parts. The first part is the anode. Here it's pictured blue. That is the negative terminal of the battery. At the other end, the pink end here, is the positive cathode. And in between the two, you have a semi-permeable electrolyte barrier. In the next slide, I'll explain, by the anode, a separation occurs that separates an electron from a positively charged ion. The electron then flows through a closed circuit to produce electrical energy, and then returns to the cathode, where it once again pairs with the positive ion. A battery functions on oxidation and reduction reactions. The oxidation occurs in the anode. That is the blue area here. That's zinc. Typically, this is some type of chemical or metal that is easily separated from one electron on its outer ring. The oxidation refers to the separation of this electron from the positively charged ion. When this separation occurs, the electron wants to find the path of least resistance to an area of low density of electrons. In the case of a battery, when a closed circuit is attached to the battery, this electron separates from the positively charged ion, travels through the wire. It's at this point that it's able to power something. Here we see the light bulb lighting up. It travels through this wire to the cathode. In the cathode, this electron meets back up with the positive ion that was able to travel through the semi-permeable solution. This unification of the electron and the positively charged ion is called a reduction reaction. A battery is able to power something until all of the possible molecules in the anode have oxidized and reduced to return to the cathode. Once all these molecules have gone through oxidation reduction reactions, the battery no longer has electrons to pass through this closed circuit, and basically the battery is dead unless it is rechargeable and the reaction is able to be reversed. A rechargeable battery works by attaching a battery that is either partially or entirely used up to a power source. Once attached to this power source, it is able to cause the reaction to go in reverse. Therefore, these molecules are able to separate once again, this time at the cathode level, send the electrons back through the wire to the anode, where they once again reunite with the ions, therefore resetting the battery. This use and recharge can be done over and over again. However, oftentimes, recharging a battery too frequently or too often will cause damages to the surface of the battery, lowering the efficiency and therefore the overall capacity of the battery as time goes on. If batteries are pretty simple and we've understood them for over 150 plus years, why has it taken so long to try and power a car with a battery. The difficulty lies in the longevity and distance a battery can power a car for. Typically, it's difficult to find a battery that can allow a car to drive more than a couple hundred miles without needing a recharge. That makes driving an electrical car impractical for most car users. Additionally, car batteries have had a hard time providing enough power for a car to accelerate quickly or haul anything. That's where the Tesla battery has been revolutionary. It not only has improved the distance a car can travel, but it's greatly improved acceleration and power as well. What is pictured here is the Tesla car battery. As well as providing power to the car, it provides structural support and a low center of gravity. Tesla has opted to use lithium-ion cells for their batteries because of lithium's high tendency to lose electrons. The battery weighs about 1,200 pounds and can power the car for 85 kilowatt hours. As mentioned before, one of the improvements the Tesla has made to the car is the distance it can travel on one charge. A Tesla battery can power the car for up to 370 miles on a single charge. The Tesla car battery can be broken up into three components: cells, modules, and the pack. The pack is the entirety of the battery that we saw before. This pack can be broken down into 16 modules, as seen in the center picture. These 16 modules are wired in series. Each one of these modules is built up of individual lithium-ion battery cells. There are over 7,104 lithium-ion battery cells in the Tesla Model S battery. Each one of these cells is basically just a small version of those simple batteries that we previously looked at. Here we see the Tesla module on the left and the cell on the right. Each module contains 6 groups of 74 cells wired in parallel. These 6 groups are then wired in series within the module. But why break down the battery into different modules? For Tesla, it's largely for ease of use and safety of manufacturing. If a part of the battery breaks, it's easier to replace one module than replace the entire Tesla battery pack. One difficulty in using batteries to power cars is that the resistance in the batteries generate heat. This heat within the center of the car can be dangerous for the different operations of the car, and also lowers the productivity and efficiency of the battery over time. That's why Tesla have been able to create a patent cooling feature on their batteries that is able to decrease the risk of overheating. Tesla has a patent cooling tube that passes through each module. Through these cooling tube comes a glycol coolant. By using many small cells within each module instead of one large cell like some other electrical cars try to do, the Tesla cars are better able to control temperature and distribute it evenly. Here we can see as the glycol coolant passes through the module, it heats up. This heated coolant is then cooled once again by passing through a radiator that is placed at the front of the Tesla car. In the radiator, the coolant cools down, and once to a cool enough level, it can be passed back through the battery to continue distributing the heat evenly. One of the cool features about a Tesla battery in conclusion, the Tesla battery pack is not that complicated. It is just a combination of small cell batteries in series and parallel, divided up into modules in a larger pack. The unique aspects of Tesla, though, are in the details, in the way in which they are able to apply these cells in series and parallel to maximize power output, as well as the unique way they're able to cool this battery off. Their use of lithium ions is able to produce a battery that is able to reach maximum capacity. And their decision to use many small cells instead of one large cell has been able to improve longevity, power output, and ease of manufacturing. The Tesla car battery is only improving. And with time, we'll see where it takes us. Thank you.